Okay. All right. So this is chapter 5, day 3, section 5.4, radical operations with binomials. Okay. So the first skill we're going to do is just how to multiply binomials. And the good news is multiplying binomials is a lot like multiplying regular binomials, like x plus 2 times x plus 3. It's actually the same exact process. The only caveat with binomials with radicals is the roots must match. You cannot multiply a square root by a cube root. They have to actually match. The process is pretty simple. You multiply scalar times scalar, and then underneath of the radical, you multiply radicand times radicand. So outsides and outsides, insides and insides. And then, of course, you simplify, but that we know. Okay, so we are going to multiply square root a plus 2 radical 3 times 3 radical b minus 4 radical 3. And other than the fact that the radicands are all over the place, these are all square roots. So yes, we can actually multiply those. So the technique that you can use to multiply is distributive property. So in distributive property, you take the first term and you multiply it by everything in the second parentheses. So we're going to have radical a times 3 radical b. So there's an invisible 1 on the outside. So 1 times 3 is 3. And then under the radical, I have an a times a b. So it's just ab. All right, now I'm going to multiply that radical a times negative 4 radical 3. So outsides and outsides. 1 times negative 4 is negative 4. Inside times inside. 3 times a is 3a. So once you've distributed the first term, then you distribute the second term. So you multiply it by everything in the parentheses next to it. And the pattern's the same, outsides times outsides, insides times inside. So here we go. On the outside, I have a 2 times a 3, which is a positive 6. On the inside, I have 3 times b, which is 3b. Now we take it and multiply by the second term. Outsides times outsides, 2 times negative 4 is negative 8. Insides times insides, I have a 3 and a 3. So 3 times 3 on the inside. Now, none of these actually can be added together. This one, though, needs to be simplified. So 2 3s, 1 comes out. So that's going to be negative 24. You put the non-radical number first or the rational number first. And then there's really not much of a pattern for the rest of it. So plus 3 radical AB minus 4 radical 3A plus 6 radical 3B. Most of the time when you're multiplying binomials with radicals, you're going to end up with 4 terms. Vast majority of the time. So again, you put the rational terms first, and then the irrational terms after that. And irrational is any term that has a radical, because if it's trapped in the radical, it's going to come out as a non-repeating, non-terminating decimal. Okay, Roman numeral 2. Okay, so to be able to divide, you need to understand something called radical conjugates. Now, you've heard the word conjugates before. We've used conjugates with complex numbers, with i's. Complex conjugates. The pattern is basically the same. So your pattern of radical conjugates, let's say if the first one is a plus b radical c, the conjugate will be the same thing except the middle sign changes. So a minus b radical c. So that's your pattern. It's only the middle sign that changes, not the a. So for example, If I give you the number -3 plus radical 2, its radical conjugate is -3 minus radical 2. If I give you the number radical 17 and there isn't a beginning number, this is the same thing as 0 plus radical 17. So if you can think of that missing real part as a 0, then change the middle sign. It'll be 0 minus radical 17, which is negative radical 17 for the conjugate. All right, the cool part about radical conjugates is when you multiply them together, special things happen. So we're going to multiply 2 plus radical 7 times 2 minus radical 7. These are radical conjugates, and we're going to use the same technique that we used above for multiplying. So we're going to take the 2, multiply it by everything in the second parentheses, that's distribution. So 2 times 2 is 4. 2 times negative radical 7 is -2 radical 7. Okay, now we're going to take the next term, the radical 7, and we're going to distribute through the second parentheses. So radical 7 times 2 is +2 radical 7. And positive radical 7 times negative radical 7 is negative radical 7 times 7. So the pattern that comes out when you multiply radical conjugates is that the middle two numbers will always add up to 0. 2 radical 7 minus 2 radical 7 is 0. And then you have a real number here. And the second one is going to simplify out. So 2 7s, one comes out. So I have a -7. So all you have is 4 minus 7, which is -3. So radical conjugates cause the radicals to disappear. And when you're doing division or rationalizing and you want the radical to disappear out of the bottom, the conjugate is how you do it. All right, Roman numeral 3. We're going to do division with binomials. Division with binomials. And of course, division is the same thing as rationalizing. All right, so example 1, we're going to do 2 divided by the quantity 3 plus radical 5. All right, so just like we did before, you're going to stack it up, 2 over 3 plus radical 5. So what's different is to get the radical 5 out of the denominator, we have to multiply the bottom by its radical conjugate, which is 3 minus radical 5. Of course, if you do it on the bottom, you have to do it on the top, 3 minus radical 5. All right, so now is the hardest part, which is the multiplying without messing anything up. So we focus as much as we can. 2 times 3 is 6. 2 times negative radical 5 is -2 radical 5. We don't really mind a radical on top. Now here we go on the bottom. 3 times 3 is 9. 3 times negative radical 5 is -3 radical 5. Now go 1 over and distribute the radical 5. Radical 5 times +3 is +3 radical 5. And then positive, this is when people mess up. On the outside, it's a +1 times a -1 is a -1 on the outside. And then you have 5 times 5 on the inside. All right, so what happens is the middle two numbers, 3 radical 5 minus 3 radical 5, go to 0. So now I've got 6 minus 2 radical 5 over 9, and then 2 5s, 1 comes out, gets multiplied by the -1, and I have a -5. So that would be 6 minus 2 radical 5 over 4. Now, to simplify this, You can't simplify a binomial with a monomial, but if you can divide a 2 out of the scalar and the front number, which I can divide a 2 or factor a 2 out, and that leaves me with 3 minus radical 5. And then on the 4 is 2 times 2. I can cancel the 2's. So I've got, I'm going to go over here. I have 3 minus radical 5 all over 2. So I always tell people if you can pull it out of the first number, the scalar, and the bottom number, it's a go. This is the same thing you do, by the way, when you simplify quadratic formula. It's exactly the same. All right, so we've got this. Now we need to do standard form. Standard form is some number A plus or minus a radical B number. So to put this into standard form, we just need to put each of these over their own 2. So 3 over 2 minus radical 5 over 2, and then we are in standard form. Real part first, irrational part first, irrational part second. All right, we're gonna do one more example, and then that's gonna be it for today. So example 2 is 2 radical 3 over 1 minus radical 2. Okay, so to divide or rationalize, I need to get the radical 2 out of the bottom. Because it's in a binomial, I need its conjugate, which is 1 plus radical 2. And that means I have to multiply the top by the same thing, 1 plus radical 2. All right, so on the top, I'm going to distribute the 2 radical 3. So 2 radical 3 times 1 is 2 radical 3. And now 2 radical 3 times radical 2. On the outside, 2 times 1 is 2. On the inside, 3 plus 2 is 6. So outside, outside, inside, inside. Over. Now we're going to do the bottom. Start with the 1. 1 times 1 is 1. 1 times positive radical 2 is positive radical 2. Now move to the radical 2. We're going to distribute that one. Negative radical 2 times 1 is negative radical 2. And then here's the tricky one. On the outside, a negative 1 times a positive 1 is a negative 1. And on the inside, I combine the radicands. I have 2 times 2. All right, so like I hoped, radical 2 minus radical 2 goes to 0. So now I have 2 radical 3 plus 2 radical 6 all over 1. And then 2 2's, 1 comes out and gets multiplied by the negative 1. So it's 1 minus 2. So I get 2 radical 3 plus 2 radical 6 divided by negative 1. And so they both have to get divided by negative 1. So I end up with negative 2 radical 3 minus 2 radical 6. There is no rational part of this. So we're done. We're in standard form. They're both irrational. All right, any questions about this process?